this video is for the student who have chosen biology over mathematics, and obviously in physics they have to go through the these three important mathematical tools, which are logarithm, trigonometry functions and calculus. What I presume that they might have been taught about the trigonometry function in 10th class. Where is that? In 10th class, but I I am sure that they have not been taught about the calculus and logarithm. Maybe in ICC board they might have been taught about the logarithm. So, let us start with the logarithm. The important thing about the logarithm, suppose you know something like 10 raised to the power 4, what will happen? You will immediately tell that it is 10 into 10 into 10 into 10. And in the same way, if you write 5 to the power 6, then what will do? 5 into 5 into 5 into 5 into 5 into 5, and up to this you may understand the value of this 5 raised to power 6. But suppose I write here 5 raised to the power 9, then what will happen? It will become difficult. In the same way, it is obviously when you raise something with 0, it is very easy. I mean, if you raise 100 raised to the power 5, then it is again easy. You will, what you do, you will write 100 5 times. Okay. So, for this, to solve this, and now come to the point, if you raise something like 4 raised to the power 6, or 4 raised to the power 16, or something like 7 raised to the power 8, what will happen? It becomes more and more difficult. So, for this is called exponential. I mean, this is when we say raised to the power, is called exponential form, exponential form. Okay. From here, logarithm is introduced by some scientist, Napier. Spelling, you may not go about the correctness of the spelling. It is Napier who invented this logarithm. So, I am writing the it is something like 18th century, which is not important for anybody. Okay. So, what is logarithm? Definition. What is logarithm? We generally write it log. I mean, we normally do not write logarithm as a whole, we write log. So, logarithm of a number is the exponent by which, try to understand, by which another fixed value, the base, I mean, I will tell you, the base must be raised to produce that number. Okay, to start with very simple thing, 10 raised to the power 3 is 1000. This is simple formula. I mean, initially we start with this. So, here 10 becomes the base, 10 is called base, and the number is 1000 is number, which is ultimately called argument. and 3 is called the logarithm, log value. What, how we write this? B, I mean when we write log, and in the downside of this log we write 10, and here we write 1000, and here we write 3. When we write in exponential form, we write this in the form of this 10 to the power 3 is equal to. So, you must have understood the how we change the exponential form to the log form. 10 becomes the base which we write down side of the log, and the value of this, which is called argument, is written at the in front of log, and the power is written in the front of 3. I mean it is whole reverse of the reverse of exponential form. Okay. So, now come to the other point. This is very simple. Now, coming to the most important thing, some logics. We normally use base as 10. When you are given some problem in physics, I mean in mathematics, you may be given so many bases. I mean you may be given something like where is that? Something like log base, they may write 7, they may write log 8 or log 5, or in the same way so many things in mathematics. But in NEET, I mean in those who are pursuing biology, they are simply giving this log 10 or sometimes log e. E is the exponential exponent, something like 2.718 is the value of E. Anyways, so now coming to some important formula. When we write in this way, you must have understood that log base 10 is always asked. Log base 10 with any value which is called the argument, which provides you the answer to that, I mean equal to that is the log value of this argument. Now, some definitions, some formula in log. Log, we just generalize, use variables log x. When we simply write log x, then it is presumed that it is either log 10x or log ex. When we write log x, then we presume that it may be log 10x or log ex. So, log 10x, but because 10 is known number, so we always use variables. So, even we can write here something like log ax. Okay. So, base is a, x is the argument. So, let me say log, this is called multiplication and addition formula, log a x y. Then this becomes, this is first log a x plus log a y. This is first. I mean multiplication in logarithm with the same base will give you the addition, which is always simple. I mean why it is used, why logarithm is used, because when you multiply some large numbers it is very difficult, but when you add these large numbers it is very easy. So, it happens when we do this log a x y, it becomes log a x plus log a y, and even if you write log x y z, okay, then what will happen? We will simply say log base a z or so many things. So, you have to add all those things. Now, number 2, log a x upon y. So, what will happen? Log a, they subtract each other, a x minus log a y. This is second formula. Okay, these are the important things, but the most important thing which you have to understand, that is the crux of this logarithm. Let me scroll. Okay. So the most important thing in the logarithm is, okay, this is the most important thing, change of base. This is generally used in the those who are studying the mathematics in class 11 and 12, then this is change of base. This is a very important thing. For example, log, suppose write log bx. So, this we can write as log something, we can change base. So, we can write log k raised to the power, I mean not power, we here use the same argument, but here downward we write log k and we use base here. This is the most important formula for the logarithm. I will tell you the how we reach to this formula. This is very important because if you don't understand this formula, you will always be confused what how we could reach to this. I mean, what will happen? Suppose somebody says this log 7 this. So what will happen? We have one thing which I forgot to tell you. We have two tables. I mean that is most tedious job which Napier has done. Two tables. One is called logarithm table, log table, and other is anti-log table. Okay. So, this I will tell you later on. So, suppose it is log 7. So, there and these tables are only, they are based on 10 or E. Either base is 10 or base is E, not any other number, not any other number. So, what will happen? Suppose somebody gives you the question like this, log 7x. What will happen? Now, you have to change this 7. So, okay, let me write it again, log 7x. Now, what will happen? What we'll do? We will make it log 10x, log 10x upon log 10 7. It is now easy. You can get the value of log 10 7 from this log table. You can also get this log 10x because 10 is universal number. So, you can get this value also. So, it becomes very easy for you to get any value of log with any base by this method. Now, just because this is very important, so I must tell you how to reach this, formula, and that will I will end up with, because this is the only thing which you must understand about the log. So, let us come to the point. Suppose we write log bx and let it become the y. Okay. So, what will happen? B as exponential b raised to the power, I mean b raised to the power y is equal to x as for exponential form. This is exponential form. So, what will happen? You will write in this way. Now, get the value of this log. Okay. What you do? Just take the value of this log by, you take with some different, suppose we write it, where is the, where is my ink? Oh, okay. So, okay, we take log, so with some other base. Suppose we write log c, we write log c, this is equal to log cx, is okay. Okay. One formula which I left, it is 4 number, which was actually have to write as a number 3, log x y raised to the power z is equal to, power becomes multiplication. So, z log x y, I mean this power becomes the multiplication. So, here what will do, y log c raised, I mean argument is b is equal to log c x. Okay. Now, y can be written as log bx. Okay. So, log bx into log cb is equal to log cx. Okay. Now, see, so log bx was the initial number which you have searched. Log bx is equal to log cx upon log cb, which I told you here, I mean somewhere here. So, this is the important thing, I mean important formula which you can use, I mean when it comes to you in the physics of class 11, then you can use this formula. The most important was, I tell you, this is the most important, otherwise you have to remember these are actually, these are the simple formula. The power in log becomes the multiplication, the multiplication becomes the addition, and division becomes the subtraction. And the most important is the clause 3, that is change of power. And I told you how to change the how power changes brings you this formula. I mean this formula, how power changes brings to this formula which I have calculated here. So, all students kindly remember those things. If you do not understand any of these things, you may write me in comment so that I can proceed. Anyways, take care and be happy with your physics. Take care. Bye.